Hello, this is the poster presentation of Abstract 88 for the NASA Exploration Science Forum 2020. The research presented here is entitled Finalizing the TREX Fine Particle Spectral Library of Minerals, Ultraviolet, Visible, Near-Infrared, Mid-Infrared in Reflectance, Emission, Raman, and Preparing to Receive Meteorite Samples. The research work was done by Melissa Lane, that's me, and all my stellar colleagues. I'd be remiss if I didn't properly acknowledge our funding that comes from NASA through the Solar System Exploration Research Virtual Institute, SURVey program. NASA is planning to send humans to the surface of airless bodies such as Earth's moon, the Martian moons, or asteroids. These surfaces are coated with dust. That is, fine particulates derived from the mechanical or possible chemical degradation of surface rocks. This dust presents a hazard to missions both in terms of operations, including hardware degradation and trafficability, as well as astronaut health. In order to study dusty surfaces using remote sensing, the TREX survey team is developing a comprehensive spectral library focused on fine particle planetary materials less than 10 microns in diameter, measured over UV through mid-infrared wavelengths. Where possible, we have acquired spectra under relevant environmental conditions. We currently have spectral data from 3 different labs, including DLR, which is the German Space Agency, the Planetary Science Institute, and the University of Winnipeg. Our team has been analyzing a suite of terrestrial minerals listed in Table 1. We verified that our samples consisted of sub-10 micron particles by analyzing them with a particle size analyzer. We found our samples to be typically 0.5 to 3 microns in diameter, with more than 90% of the entire sample suite at much less than 10 microns. Clearly what could be categorized as dust. This slide shows our improved UV through UV-VNIR-MIR data and compares the mineral reflectance spectra that were acquired at the 3 previously mentioned labs. We are very close to having acceptably similar mineral spectra from each of the labs. The poster offers a brief discussion of the differences. These individual spectra and a Frankenspectrum, that is, a spectrum made of each mineral using the best spliced pieces from the various individual lab spectra, will be archived in the Planetary Data System Geosciences node. Please note that we also have mid-infrared, reflectance, emission, and Raman data of all these mineral samples too, but space limitations did not allow us to include those graphs. Further work includes acquiring XRD data to verify the sample compositions and possible contaminants, developing a better UV standard for all the labs, and acquiring Mussbauer spectra of the minerals. We are also eagerly awaiting the meteorites from Johnson Space Center to finalize that sample suite that you see in Table 2 and begin all their spectral analyses. Thanks for checking out my poster.